Good morning, this is your stats sensei, Mr. Spensey, and we're going to do the warm-up for our test review. So, and this is going to be focusing on paired data. So oftentimes parents of students have had bad experiences with statistics courses and pass on their anxieties to their children. To test whether actually taking high school statistics decreases students' anxiety about college level statistic, and a high school students statistics teacher gave a test to rate students' anxiety at the beginning and at the end of the course. Anxiety levels were measured on a scale of 0 to 10. Here are the data for 16 randomly selected students from a class of 180. The difference in anxiety levels, pre-course anxiety minus post-course, follow a normal distribution. All right, test to determine whether or not anxiety levels decrease after the course. So what we're interested in here is anxiety levels. And since we've been tested twice, this is going to make this as a paired. So let mu d equal the true population mean of the differences. And what were we interested in measuring? Well, we were interested in measuring anxiety. So in anxiety level, and we're going to have to show our subtraction, which in this case is pre-course minus post-course. Pre-course minus post-course. And we want to see if they decrease afterwards. So if this is decrease, this is going to be the small value, and this is going to be the large value. So it doesn't really much matter what I choose, but let's say for the small value, I choose the number 6, and the large value is greater. So this tells me pre-course should be greater than small course. I mean, pre-course should be greater than post-course. So HO mu D, what we have here is what we're going to have to go with, greater than, excuse me, the null hypothesis is always going to be equal to 0 because that's indicating there's no difference. And then this is going to be mu D is greater than 0. All right, our formula. So T equals X bar minus mu S divided by square root of N. I'm going to go ahead and drop some D's on it because we're talking about the differences. Now the question is, why am I not using a confidence interval? X bar plus or minus T star S divided by square root of N. And we drop some D's on that as well. All right, so the confidence interval. I should use the confidence interval if it says confidence interval. It doesn't. It says test, and it gives me another hint. It tells me my alpha level is 0.03. Because it gives me an alpha level, it says test. I know I should be using this one here, not the confidence interval. All right, so I should not be using the confidence interval. So the key words here are alpha, test. It could have said level of significance, and that would have also indicate that I was going to be using a t-test. All right, scenario 2. When a virus is placed on a tobacco leaf, small lesions appear on the leaf. To compare the mean number of lesions by two different strains of virus, one strain is applied to half of each tobacco leaf, and the other strain is applied to the other half on each. The strain that goes on the right half of the leaf is decided by coin flip. The lesions appear on each half and are then counted. The data are given below. Determine at a 0.05 significance level whether or not virus strain 2 produces fewer. All right, so we're looking at the number of lesions, and we notice each leaf is tested twice. So let mu D, the fact that it's tested twice lets me know it's a paired, and I need to be using mu D as opposed to mu. Let mu D equal the true population mean of the differences in number of lesions And we're going to go strain 1 minus strain 2. Now here's what I know. They said they want to see if strain 2 produces fewer. Well, if this is fewer, this is more. And let's say I choose a number for 10 for more, then this has to be less. So this tells me I need to be working with a greater than. So my null hypothesis is HO. We expect no difference. So no difference means 0. And my alternative is mu D is greater than 0. All right, how do I know which formula to use? Well, it says that at significance level. That tells me I'm using the t-test formula. So T equals X bar D minus mu D over SD divided by the square root of N. It didn't say confidence level and it said significance level. That lets me know that I'm using the t-test as opposed to the confidence interval. All right. Appreciate you watching. Hope to see you on the next one. Thank you.